In this video, we're going to take a look at another quotient rule example. So in this video, we're going to look at f of x equals square root of x over ln x and use the quotient rule to take its derivative. All right, before you do anything, you want to rewrite that square root sign in terms of the fractional exponent, right? So the square root of x is the same as x to the 1/2 power. So this is the quotient or division of two functions, right? So we're going to use the quotient rule to take the derivative. So the quotient rule is going to be low, right, which is x, d high, right, the derivative of the top function. It's going to be 1/2 x to the minus 1/2 using the power rule, right? This is a power function on top, so bring this down and subtract 1 from the exponent. Minus high, right, x to the 1/2, d low, that's 1 over x. Okay, the derivative of ln x is 1 over x, and then over low squared. So natural log times x, or natural log x times natural log x, which we write in this compact notation with the exponent right here between the name of the function and the parentheses. Okay. All right. So now we're done taking the derivative. We've got a lot of simplifying to do here. So first off, what I want to do is to right here, put this negative exponent down in the bottom part of the fraction right here. So I'm going to do that. So move that x to the 1/2 down, right? Or x to the negative 1/2. And when I move it down, I change the sign of the exponent. So in the bottom part of this fraction now, I'll have 1 over 2x to the 1/2 power. Then over here, right, I have x to the 1/2 power times 1 over x. Okay, and so that is in effect going to be x to the 1/2 minus 1, right? So x to the negative 1/2, which I can also put down in the bottom part of the fraction right here. So if you think about it, another way to look at it is I've got x to the first power right here, right, with the understood 1 exponent. Then I have x to the 1/2 up here, right? So if I cancel out a half, right, I'll wind up with a half a power of x on the bottom there. Okay. Then here in the next step, I'm just multiplying this fraction out, putting the ln x, multiplying it times that 1 on top. So that's what I have up here. All right, so I still have a complex fraction, right? That is a fraction with fractions in the numerator or denominator right here, and I need to get rid of that to make it as simple as possible. And so what I'm going to do is get a common denominator for these fractions up in the top and combine them into one big fraction. Okay. So there's what I've got. And so looking at these two fractions here, this one has a denominator of 2x to the 1/2. This has a denominator of x to the 1/2. So the common denominator would be 2x to the 1/2 power. So that's what I'm going to do here is multiply the top and bottom by 2, right? So that I will get a common denominator here. So if I actually carry out the multiplications, 2 times 1 is 2, 2 times x to the 1/2. So I have 2 over 2x to the 1/2 power. So now the two fractions in the top have a common denominator, right? So I can go ahead and combine them into one fraction, right? And recall the way you do that, right, is if two fractions have a common denominator, then you just combine the numerators here, subtract them, ln x minus 2, and keep the same denominator here. Okay. So now I have one big fraction on top, and I am dividing by ln squared x. I still need to carry out that division, right? So if you're a little bit rusty on that, right, how you would do that is to put ln squared over 1, right? And now I'm dividing two fractions. I have this fraction here on top, and I'm dividing by this fraction here on the bottom. So how do you divide two fractions? Well, you invert, right, the bottom one and change it to multiplying. Right, so here's what I've got, and then I'm going to change that to multiplication, and I left a step out here, but so I would flip this one over, right, and that 1, when I flip it over, would multiply times the top, ln x minus 2, and then the ln squared x would be on the bottom, and I would multiply that out. And so I would wind up with the ln x minus 2 on the top, and the 2x to the 1/2 times ln squared x on the bottom. And so now this is not a complex fraction anymore, right? And it's about as simple as I can get it.